Have you ever, taken off a sweater and had your hair stand on end? Or just watched a lightning storm and wondered about the raw power behind it? Well, it turns out it's all governed by one single fundamental rule. So let's get into it and really uncover this invisible force that pretty much shapes our entire world.
We're basically surrounded by signs of this powerful, unseen force. It's in the static cling you get in the laundry, that little shock you get from a doorknob, and yeah, even in the incredible power of nature itself.
We've all been there, right? You see that tiny little spark jump from your fingertip to something metal. And then on the other hand, you can witness the sky just rip open with a huge lightning strike. It's crazy, but that's the exact same force, just playing out on wildly different scales. So here's the big question. What's the invisible rule behind all of this? How can a force act across empty space, pulling things together or pushing them apart when they're not even touching?
Okay, so the answer starts with something called electric charge. It's a fundamental property of matter. The best way to think about it is like this. Just like mass gives things gravity, electric charge gives them an electrical push or pull. It's not something added on, it's just part of what makes up the universe.
Now here's where it gets really interesting. Charge comes in two distinct flavors. You've got positive charge, which is carried by protons that are locked away deep inside an atom's core. And then you have negative charge, carried by those little electrons that are always zipping around the outside. And these two types of charge? They follow one beautifully simple rule. Opposites attract and likes repel. That's it. A positive and a negative charge will always pull toward each other. But two positives or two negatives will always push each other away. It's this constant, fundamental dance of push and pull. So, we've met the main players, our positive and negative charges. Now let's open up the rulebook that describes exactly how they behave with, well, mathematical perfection. It's a little something called Coulomb's law. Way back in 1785, a French physicist named Charles-Augustin de Coulomb cracked the code. He figured out a law that perfectly describes this force, and what it says is pretty straightforward. The force all depends on just two things: how much charge the objects have and how far apart they are from each other.
And there it is, the law in all its mathematical glory. Now, I know it might look a little intimidating, but trust me, it's really just a simple sentence in math speak. It just says that the force F is equal to the two charges, Q1 and Q2, multiplied together and then divided by the square of the distance between them, which is r squared. Let's just break it down real quick. F is the force, that push or pull we're trying to figure out. Q1 and Q2 are just the amounts of charge on each of the objects. Makes sense, right? Bigger charges, bigger force. And R is simply the distance between them. That K is just a constant number that makes all the math and the units work out perfectly.
Now we get to the really cool part, that r squared on the bottom of the equation. Why is the distance squared? Well, you have to imagine that a charge's influence radiates outward in every direction at once, kind of like the light coming from a light bulb or the sound from a speaker. It spreads out over the surface of a sphere that gets bigger and bigger.
Here's a perfect analogy. Imagine you have a can of spray paint. If you spray a wall that's right up close, you get a really thick, concentrated dot of paint. But if you back up and spray a wall that's twice as far away, that exact same puff of paint has to cover 4 times the area, so the paint is spread way, way thinner. The electric force works the exact same way. Okay, so we've got the rule down. But there's still a bit of a mystery here, isn't there? How does one charge even know that another one is over there? I mean, how does this force travel through what looks like totally empty space? This was actually a huge puzzle for physicists for a long time. How can a proton in one spot have any effect on an electron way over there with literally nothing between them? Is it some kind of magic? Well, not quite. The answer is something called the electric field. You see, a charge doesn't just reach out and grab another one. No, what it does is it creates this invisible force field that fills the space all around it. And when another charge wanders into that field, it's the field itself that tells that charge which way to go and how hard to get pushed or pulled. The field is the messenger.
So this might all seem like a simple rule for static electricity, but its importance, it's almost impossible to overstate. This one law and the field that carries its message are absolutely fundamental to the structure of, well, everything.
Let's just try to put its power into perspective for a second. Inside a single atom, the electric force that's pulling an electron toward the nucleus is trillions of times stronger than the pull of gravity between them. At that tiny scale, gravity is so weak it's basically irrelevant.
The electric force is the undisputed heavyweight champion of the atomic world.
So you see, Coulomb's law isn't just about little sparks. It is the reason electrons stick around a nucleus to build an atom in the first place. It's the reason those atoms then bond together to create molecules. It powers all of chemistry, all of biology. This one simple rule is, quite literally, the glue that holds you, me, and our entire world together.
And that leaves us with one last really fascinating question. If this force is so unbelievably powerful, why isn't everything in the universe either crushing together into one giant clump or just violently flying apart? What is it that keeps everything in balance? Something to think about.